Welcome to the third part of this series, where we will be preparing clothes made with Clo for use in Unreal. After exporting the mannequin you have created with Modeler, you can import it to Clo by going to File, Import, OBJ. You can also import FBX, Alembic, and other formats. At the options, leave Open and Avatar on, and all the auto options off. You may want to set the model on the ground. The scale will depend on the size of the model in Modeler, and you might need a couple of tries to make sure the avatar comes in at the same size as the outfit. The default axis setup will work for Modeler. Just a couple of notes on Clo before we get started. I created a deliberately simple set of clothes so that all of the detail that we'll work on will be on the textures, which we'll make using Substance Designer. You can, of course, use any outfit or garment that you like, and the same techniques will still be relevant. So we have a long, light, flowy, round dress that is going to be simulated and animated with wind in Clo. And on top of it, we have a hoodie that we're going to use, on which we're going to apply textures, but also sculpt it with a displacement map. Using parametric materials made with Substance Designer on meshes has the advantage of being able to create many different styles. You can detail your clothes without having to directly and permanently work on the mesh. This way, you can create many designs easily and quickly. With that in mind, let me start showing you how to prepare an outfit so you can texture it with Substance tools and then animate it in Unreal Engine. I won't cover garment construction here, as there are better tutorials available for that on the Clo YouTube channel. So once you have your outfit ready, go to Display, Environment, Wind Controller to turn on the wind controller, place it and rotate it so that it's blowing directly at the front of the avatar. You also want to select all of the patterns in the 2D view and turn their particle distance to 10. This is a good number for creating an animation to play in Unreal. Next, freeze all the parts you don't want to animate with the wind. In this case, I'm freezing the jacket and the upper part of the dress. You also want to make sure that you're freezing any garment that you want to apply displacement to in Unreal, as you can't apply displacement to animation caches. In my case, I'm freezing the jacket as it's supposed to be made from a rigid fabric, and I also plan to apply displacement to it. You can now play the simulation to test the wind on the dress, and with the dress pieces selected, you can go in the Properties editor and test it with several fabric presets. In my case, I'm using a nylon featherweight material, and it seems to be working well. Once you're happy with how the dress moves, freeze it and unfreeze the jacket to refine its draping before exporting it. You can also pin things in place using the Tag to Avatar tool, for example if you don't want the hood to drop. Pull the garment to drape it as you like with the simulation on, and pin to the avatar any other parts that seem too loose. Before recording the simulation, freeze the jacket again and unfreeze the dress. Time to work on the UV layout. So let's go over to the UV editor. You can use several UV tiles for the dress, but you have to use only one UV tile for the jacket because we want to use displacement on it in Unreal. To compensate for the reduced space, you can use higher resolution textures. 8K textures will be enough for this jacket. Let's now select only the jacket and export it by going to File, Export OBJ selected. In the options, select Single Object, Weld, and Unified UV Coordinates, and keep the rest of the default settings. Go over to the Animation Editor, record the simulation, and then export it as an Alembic Ogawa cache. In the options, select Unweld, Thin, Unified UV Coordinates, 30 frames per second, Entire Region, and then hit OK. Let's also export the avatar as an OBJ, especially if its scale has changed during or since importing it to CLO. In the options, select all avatars and keep the rest of the default settings. Make sure that you export the garments and the avatar at the same scale. I've used centimeters for all of them here. One last thing that you need to export is the flat panels of the jacket. This will help us a lot with retopology later on. Simply select all of the jacket pieces, right-click on them in the 3D viewport, and select Reset to 2D Arrangement. And then, with the flat panels selected, export them as OBJ selected. And use the same settings as for the jacket earlier. I'll be using Maya for retopology, although Blender or other programs work too. The goal is to retopologize the jacket without losing the UVs from CLO. After importing the Alembic cache you exported from CLO into Maya, detach the jacket from the dress by selecting the mesh and going to Mesh Separate. Then, select all of the dress's pieces and re-export the dress animation alone as an Alembic. To begin retopology in Maya, first import the draped jacket and the flat panels you exported from CLO. Let's also make a copy of the flat panels. This second copy will serve as a guide. With that done, let's start the retopology. To initiate the process, select a single copy, navigate to the Mesh menu, and choose Retopologize. In the Retopology options, you can select Edit and then Reset to revert to the original tool settings. Next, set the target face count to something very low, like 400 or 500. After hitting Apply, this will create a well-structured topology from your two-dimensional panels. Sometimes the new pieces don't align perfectly with the old ones, so there are differences on the external edges and corners. To correct this, we can snap them back onto the original pieces to ensure that their edges align perfectly. The internal topology of these pieces can vary, even if it is always regular quads, as long as their edges correspond exactly with the original edges. If the topology results are not good, you can always adjust the target face count and try again. To maintain identical topology on both sides so that they can be merged, first retopologize one side of the garment and then mirror it. Simply erase these, keeping only one side of the pieces, and then duplicate that side. While deleting pieces, take care not to delete any original triangulated pieces at the back. That's the duplicate of the flat panels we created earlier. Best thing to do is place them on a separate layer and lock them. Now you can go in vertex mode. To switch to this mode from object mode, simply right-click on the object and select vertices. Now you can select vertices and snap them onto the edges of the original piece. Make sure you are pressing V on the keyboard while doing this to have snapping active. It's okay if some edges slightly deviate from the original piece, but try to keep these deviations to a minimum. We will later subdivide and smooth the pieces, and they will align closer to the original outlines. Let's now deal with the symmetry. Once you finish the edges, select all the new pieces and separate them through the Mesh Separate command. Then in object mode, select each one, duplicate it with Ctrl D, center its pivot by going to Modify, Center Pivot, flip it over by setting its scale X to -1, and position it over the mirrored guide piece. Try to be accurate here and snap to one of the corner points or the origin of the guide pieces if that helps you. After duplicating and mirroring each piece and having them all in place, select the new pieces and choose the Mesh Combine command. This operation makes handling them easier as one object. It's also a good idea to delete the history at this point, as Maya always keeps the history of all operations on each object, and that can sometimes lead to unexpected results. Now that you have your retopologized pieces superimposed on your original pieces, you can use the command position to transfer the original UVs to the new pieces. This is necessary as retopology causes models to lose their UVs. To transfer the UVs, use the Transfer Attributes tool from the Mesh menu. In the Attributes to Transfer section of the options, turn everything off except UV sets. Set the sample space to world, ensuring that the UVs are transferred based on the world placement of the pieces. Next, choose the source and target pieces and then click Apply. This step allows the new pieces to inherit the UV layout of the old pieces, effectively placing them in the same positions on the UV map. We will need these to later place the retopologized pieces on the draped jacket. If you now unhide the draped jacket, you'll notice that the same UVs exist on both the draped jacket and the retopologized pieces. In other words, the original jacket's UVs have now been transferred to the new pieces. Use the Transfer Attributes tool once more, this time to transfer the vertex positions from the jacket to the pieces. We can do this now as we have the same UV topology on both. So vertex position on and sample space UVs. After selecting the target and source and applying the transfer, the retopologized pieces will take the shape of the draped jacket. Let's now connect the pieces by merging their edge vertices. Unfortunately, we have to do this manually. Just select corresponding pairs of vertices and use the Merge Vertices command to merge them. You can find the Merge Vertices command in the Mesh menu. The Mesh menu gives you options to select, delete, and reconstruct edges to enhance the flow of your topology. You can add extra loop edges or delete and reconstruct them to get a better flow. Try to make the topology as consistent as possible. Thankfully, we're still working at a very low resolution, so the manual work is not too much. You can also move the pieces apart if this helps you select vertices more easily. Now that everything is merged together, the topology is not perfect yet, but let's smooth the jacket and redrape it around the original jacket. To smooth the mesh, go to Mesh Smooth and select the default settings to smooth exponentially once. Let's return to the Transfer Attributes command. We want to use the common UVs again to wrap the smooth jacket around the cloth once more. You will notice that the result comes closer and closer to the shape of the original jacket. Let's now use our sculpting tools to refine our new jacket. This helps achieve a more natural appearance, especially around folds. Let's start with the Smooth tool. By double-clicking the box next to it, you can tweak settings, size, and strength. Then you can smooth out anything that looks too sharp or too unnatural, bearing in mind that going too far can distort the mapping of your UVs on your polygons. You can further optimize the UVs by using the Unfold tool. While optimizing can be useful, make sure to strike a balance to avoid losing the original shape of the patterns. It's important to maintain a compromise between UV distortion and overall optimization. You also want to check for any interpenetrations with the mannequin or other parts of the garment and fix them. The Grab tool will be your friend here. Again, try not to drag things too far, or you might stretch the polygons against the UVs, potentially distorting or stretching textures. Let's make this appear a little more natural. Recall that we had placed some pins when draping the jacket in CLO. The Smooth tool can help rectify some folds, wrinkles, and natural imperfections. To give the jacket thickness, you can extrude it by pressing Ctrl+E and adjusting the local translate settings. This will create a solid surface for the garment. To separate the inside of the jacket from the outside, select the outside UV shells and go to Edit Mesh, Detach, followed by Mesh Separate to separate them. This will create two separate meshes for the inside and outside of the jacket. We can now export the final result for use in Painter and Unreal Engine. This concludes my process of preparing clothing for texturing and rendering. Thanks for watching. In the next videos, I'll create materials for the dress and jacket using Substance Designer.